Hi everyone, I'm Karina Suarez and I wanted to show you my project for Stanford Coding Place. So I have been studying algorithms and I decided to make a notebook with some of them. I divide the notebook in two parts. The first part have the sorting algorithm that are a little bit more naive, and the second part have the divide and conquer algorithms. So let's start it. First we have bubble sort, that is a pretty straightforward algorithm and a little bit naive. What bubble sort does is that identify adjacent pair of element and swap them according which one is the smaller. In this case, we have the bubble function that take one parameter, an array of n elements. We can see here that we have a nested for loop, a nested structure, a double for loop. That is one of the reasons why the function takes too much time running, because we have to scan the array more than once sometimes. Also have a bunch of comparisons. So I use a sample data of an array of 10,000 elements without duplicate. What we are doing here, reading the file, strip the lines, and appending to a list. So what we're doing here is counting the time the function take the function to run, and we are calling the function. Let's see how much time take bubble sort to run. It's going to take a while, so be patient. The arrays already sorted 10,000 elements, and you can see here that it takes almost 12 seconds to run. That is the reason why I put a little bit sun inside, a little bit of sun. So we have here selection sort that is alike to bubble sort. We have also a nested structure. So let's start with the divide and conquer algorithm. The idea of the algorithm in divide and conquer is that you take a problem and break it into a smaller subproblem which you can solve recursively. Then you combine the result and you solve the problem. First we have merge sort algorithm. This algorithm uses recursion. In this algorithm you divide the array into half till you have single elements. We have here the merge algorithm, the merge sort algorithm. One thing that you have to take in mind when you are doing algorithms that have recursion is you have to have the base case, because when you have an array of 1 or 0 elements, mean that the array is small enough, you don't do any recursion. In that case, you return some trivial answer. In case that you have more than one element, you divide in half, divide the left part, the right part, then use recursion, and then merge the two halves. In this case, the function merge sort, what it does is keep the balance between the number of elements that are in the left array, the left part of the array, and the number of elements that are in the right part of the array. Let's see how much time takes to the function merge sort to run. It takes less than a second. We have here the function quicksort, but we don't going to explain this. A little bit more complicated. You have to select a pivot and doing a bunch of things. Let's keep going. What we are doing here is creating function to see how much time take the sorting algorithm to run and compare between them. So we have here the function bubble sort and selection sort that are alike. This one are the naive one and take a lot of time to run. These are not a very good algorithm to use if you have a larger data. Bubble sort, the best case of bubble sort is and complexity time and constant time for the swap. One advantage, bubble sort is sorting in place, so you don't need auxiliary time to store a little element. The worst case for bubble sort is when the array is sorted backwards, so you have to run the array more than once. And the best case is when you have the array already sorted, so you scan the array once and don't do swap, so constant time. Selection sort is kind of bubble sort, so I'm going to explain. The average, the best case, and the worst case are like the same. One of the advantages that have selection sort is that also is sorted in place. In this case, we have merge sort and quick sort. Quick sort is a little bit faster than merge sort. We have merge sort that the complexity, time, the best case, the average, and the worst case are all NLK. One of the disadvantages of using merge sort is it's not sorting in place, so we have to use auxiliary space on memory to save the list of elements. Quick sort have the advantage that is sorted in place, so you don't have to use space on memory for store anything. And the average case is n log n, and the worst case is n squared, but you usually have average because you have like options like using if you use a random pivot, you are more likely to have an average case. So I hope that you enjoy my presentation. Thanks.